Alright, let's do a quick exercise with vectors real quick. So vectors, what they are is it's a class that's been written that handles data just like an array. The added benefit with the vector though is that you can create these dynamically, meaning that you don't have to statically define a size. You can have a vector that's completely empty. You don't have to do any of the constant stuff with the array. Now, in pointers, we do discover that we can make a pointer and then put a dynamically allocated array with that pointer. It's essentially the identifier of an array and a pointer. They're the same thing. So you can dynamically create an array by allocating the memory to the heap. We can't put it on the stack because the stack is predetermined once the program launches. But at runtime, we can allocate memory to the heap to create a dynamic array. Now the vectors already does that, so we don't have to worry about that. If you do continue in C++, you will adopt the vector. It is nice, it's powerful, and you'll carry this on through your higher end classes as well. Let me kind of show you how it works a little bit. First thing we need to do is we need to include vector. Sorry here, there we go, vector. Alright, and what I'm going to do is I'm going to show you how to declare a vector. It's a little tricky, and the only reason being that this is different from anything else is because it's a class that was written for the language. It's not built into it, so that's why we have to grab the library, and then now we kind of have to do something a little off for this. So what we're going to use is we're going to use the word vector. Let me move this thing here so it's not in my way. Okay, and then after the keyword vector, you're going to have a series of chevrons. So the chevrons, what they do is they specify the data type. So in this case here, if we're going to make a vector of type int, we need to specify the keyword vector and the type of vector that we're going to create. In this case here, it's a vector of ints. Now the vector and the array, again, you're going to see like the same functionality between the two. Okay. After those two there, we need to name this thing. So we're going to call this nums. I'm just going to elect to call it nums. I'm going to put some numbers in here, so that's what I'll call it. And let's see, what can we make here? Let's make just a real quick adding program. So I'm going to go ahead and make a let me make a function that's going to return the total of the added numbers. So I'm going to call it add nums. Okay. And since I specified that this is going to be an integer return, I need to have a return statement, and it's going to return an integer. I don't know what that's going to be, but I'll go ahead and figure that out once I'm ready to do that. What I'm going to need to do is I'm going to need to pass this vector. Again, I've created a vector here. I noticed I didn't have to define its size or anything like that. Now if I wanted to, I can define the size from the start. You can declare all the elements within it just like you would with an array, and it's pretty much the same thing. So in order for us to populate this vector here, because it's empty, there's nothing in here, let's go ahead and make an integer, and we'll just call this how about limit. That's how much are we going to put inside of this vector. And we'll see out to the user. We'll assume they know what we're doing, and they will, because it will be us. And I'm going to go ahead and see in that amount via limit. Now whenever we add something to the vector, we can do that a couple of different ways, but in order to push something onto the back of the vector, meaning all of the elements go sequentially all the way through, element 0, element 1, element 2, element 3, and so to put things just inside of the vector here, we're going to use a function. It's a member function that's called pushback. So there's popback, which is remove an element off of the end of it. So they kind of stack up like a series of rings here. So whenever you pop one off, it comes off of the back, so the very last element gets popped off all the way up to the first element, which is 0. And same thing when adding, you add onto the back of it. So it will dynamically resize depending on how many you add, so it won't freak out. So we're going to add a for loop here, and we're just going to say for int I. We're going to set that to the first element, which is going to be 0. I is less than, and now here's a cool thing that we're going to use with limit, because that's going to determine how many numbers we're going to add to the vector. And then I plus plus for iteration. All right, and we're going to go ahead and go ahead and cap it off for here, and we'll go ahead and have nums, and then we're going to use dot pushback, which is a function, and that function takes the argument, the value to push onto the back of it. So in this case here, I'm going to add, I'm just going to add I to this. That way it'll be whatever I is. So it'll be, in this case here, if I put 4, it'll be 0 plus 1 plus 2 plus 3. Makes sense? So that's 4 elements, 0, 1, 2, 3. All right, so it's going to add those to the vector, and then I'm going to send, now I want to make sure my terminology is clear. That's going to assign I to element spaces. Then it's going to go into this function here to actually add them to accumulate the total, what is all of the elements added together. So that's just what this little program is going to do. All right, so now that we have added all of the elements to the vector with an unknown size that will be determined at runtime, so that's very powerful. Again, we're not limited by the stack anymore. This is all dynamic. And then we're going to go ahead and call that function right here. So I'm going to just put a comment right here saying this is where I'm going to call the function. And let's go ahead and build this out here. So how do I pass as an argument this vector? And simultaneously, I mean, how could I have a vector? Could I pass in a vector, do something, and then return the entire vector? I definitely can. I mean, all I would have to do would be to specify that this is a vector of type int as a return. And now this function will expect to return an entire vector. Now I'm not going to do that in this example here just because I just want an integer representing the total of all of the elements added together. But just so that you know, you can have a function return any data type you want. So any data type, doesn't matter. Here we go. We're going to accept in the argument function parameter list here. We're going to accept a vector, and that's going to be of type int. And it's going to be, you know, generic. We could use this over and over and over. So what if I just put x up there? That way I have whatever vector coming in, and then I do some stuff, and then I can return a total. So I know I need a total, so I'm going to go ahead and have a total. It's very important that I initialize that to 0. That way we start adding at 0 instead of some crazy unassigned number. And then we're going to start another for loop. Int I equals 0. I is less than. Now, here's the cool thing about vectors as well. Because they've been added to the language, they can, there's functionality that's been written for these vectors that will allow you to see how big they are, how many elements are contained within this vector. So to do that, all you have to do is just use the member function that is associated with that, and that's vector.size. And you have to make sure that it's open and close parentheses, again, because that's a function call. And then I++. So the cool thing about this here is that with the vector here, you have .size. This will return the size. Now this error here is because while I'm talking, I just said the vector, and so I made this generic. My vector is actually named x, so this needs to be x.size. Okay, so x, whatever the vector's name is, and then .size. And then you can go ahead and open and close parentheses, and that will call that member function to return an integer representing how many elements are contained within inside that vector. And then, of course, we're just going to iterate over the top of that. So for loop, I'm putting these braces in. You can omit these braces in this case because I'm only going to have one statement. And that's this, the x element. Again, too, these brackets come back into play again. You can treat the vector just like an array in most cases here. So the way that we access an individual element of this vector here is just the same way as we would an array. Okay, so we're gonna have total here, and then we're gonna say plus equals whatever is in x at the ith position here. So whatever I position element, we're just going to add that and accumulate that to total. Then at the end, we're going to return total. Okay, and so that should take care of everything. We need to do two things. We need a prototype, and we need a function call to actually call this function that we've written now. So I'm going to go ahead and do the prototype now. Easiest way again is copy paste, pop a semicolon on there. I don't need the identifier just in case if I do change it. That's fine, good. And I just need to call this. So to call it, I just need to add nums and then open close parentheses. I need to push, it's expecting a vector. My vector up here in main is nums. So I'm going to pass that as an argument. Right, so now I'm going to get the total back. Let's go ahead and see out the total just so that we can verify. Cool. All right, and that should be everything that I need to do. So you can kind of see what's going on. All right, so let's go ahead and run this. How many elements do you want? I'm going to say 4. With that, we should have 6. That would be 0 plus 1 plus 2 plus 3. Okay, so 4, we get 6. There it is. Just to show you what that looks like. Again, that's 0 plus 1 plus 2 plus 3. There it is. Okay. So this can go up to any size. If I were to run this again and say 100, we get 4,950, because that's every single number added against its previous or next up, altogether summed. So that's a real quick intro into vectors. There is a lot of documentation on Blackboard for this. Now, I don't cover this topic very extensively only because I'd like you guys to have a more rudimentary understanding before you enter the next class, which is 17A. So 17A does deal more with object-oriented programming, and it also gets you back into collections of elements and arrays and vectors and all that sort of stuff. So this is not a topic that is covered very much in the class, so just want to mention that. But here's a good kind of introductory use with it, and how vectors can be very powerful as they can size up to a really large size or size down, and all of that's done at runtime. We don't have any of the problems that we had before with the statically created array, where everything is done on the stack instead of the heap now that we're on. The heap is really just your pool of system RAM. Okay, so we can make this really large. So whatever you'd like to use them for, go have free reign on vectors. You will come across this again in your higher up dealings and whatever your educational goals are with the language. So it's a really good thing to get a hold of. So hopefully this helped, and thank you guys for watching.